everybody. It's Mike Levin on Saturday, April 3rd, 2021. I am uploading a video to YouTube right now on the same phone where I am shooting this new video. I used to not be able to do that on the iPhone, I know that, but I also know that several generations have gone past between the upgrade cycles I've really participated in. And I've sort of jumped from the iPhone 6 generation to the iPhone 10 generation. And there's been some pretty big operating system pushes since that. And real multitasking is occurring. What do you know? And I guess it's like less conservative multitasking that is willing to take a risk on letting something which is allowed to multitask in the background, because when it used to not work, it was still part of the days where you could say background processing on for YouTube. Yep, go ahead. You can background process all you want. However, the upload in the background would always not proceed. In fact, it was pretty unsafe to even surf away from the YouTube upload page. Even to let your screen go black was a risk of interrupting that mobile YouTube upload. And so it works like a dream now. It's really amazing. We're going from this point of, extremely being made aware of the shortcomings of the physical hardware, the blocking I/O, the lack of concurrency that, often is a characteristic of, first generation stuff, because the networks aren't as fast as they could necessarily be. You don't have multi-channel multiplexing built into the protocols necessarily on the first generation stuff. And after a few generations go by and the hardware gets faster and the bandwidth gets cheaper and the protocols get better, you can cram a lot more bits for the dollar through the same pipelines. Is it the same pipelines if there's hardware upgrades occurring? So there's always little hardware upgrades occurring out with the old and with the new, and lots of lookup tables for as many layers as you try and strip out to pursue efficiency. There are that many different new lookup tables being inserted in because routing efficiencies, because if you do the work once to figure out the shortest path between two distances, that path might as well be cached somewhere, because the network doesn't change that much that it can't use what it learned on one of the go-arounds to optimize all subsequent requests. And then that creates a sort of memory in the system, and then there's all the rules about how long that lasts, can it, and under what condition does it get purged or cleared out, that kind of memory. And so at some point, everyone realizes the advantage of having something that works a lot like a traditional SQL database, something that does lookups based on keys, that gets back maybe structured data, tabularized, structured data, row and column structured data, so you can step through it like records or data, sets, rows within a data set. And different views of the world. And the truth is that the work you do for relational database management systems, the multi-column work, is the same work you do for NoSQL systems. It's just a question of, are multiple columns supported? If you take a system like that and you say, just 2 columns are supported, so you can do basic key value stuff, and we put all our optimizations into those, key value manipulations, you've got what is labeled a NoSQL database, things like Redis and Memcache that are really optimized for that kind of behavior, persistent hash tables. Bigtable, Google went that way when they had to create the technological infrastructure to back-end Google Docs, because they were giving away Google Docs for free, which includes Google Sheets, all that spreadsheet, on the fly databases, new databases created. The killer app of the web that kind of killed a lot of the intranet, a lot of the Ruby on Rails, the kind of slamming out basic CRUD, create, record, update, and delete CRUD apps of intranets where, records were kept for the company. Who needs all that custom development work when it's just file new in a Google spreadsheet? And that's just as collaborative as anything you can develop custom, and tons easier than anything you can develop custom in, say, Ruby on Rails. So, the expectations truly changed because of Google Docs, Google Spreadsheets. In particular, corporate databases, the intranet became, directories of files in Google Docs. And, that's not the whole story, of course. There's plenty of competitive products at these times that, have different spins on it than Google Doc. Most of them collaborative and cloud-based with just slightly different spins. And of course, Microsoft struggling to keep the old school install of, Microsoft Office relevant and front and center, which is increasingly difficult as the computing platforms become more heterogeneous, with more people taking up Linux desktops and with Macs continuing to hang on with popularity. So, Microsoft has to decide how many versions of Office they're going to support. And, different bets are placed on technologies, and different habits are attempted to be formed in the way Microsoft controls startup. They're bringing back the days of the instant, always there web browser. And, there's been the preliminary flurry of articles that complain about it, that try and draw a picture of it blowing up in Microsoft's face. The first way they tried to incorporate like a web browser deep operating system and integration and, performance and preloads and stuff in, when they were went after by the government for antitrust because of Netscape. They were killing the Netscape competition. So now Google has borrowed Microsoft has borrowed all the Google Chrome code to create Edge. They're trying to make it so fast that you just wouldn't even think to install Chrome as a bloated third-party browser when the built-in Edge browser is just so blazingly fast. It's like already loaded in there, right? Just ready to pop open. When you go to the Edge icon, it comes up so fast that it makes you feel silly for adding Chrome on top of it. It just makes you feel the inefficiency of it all. So Microsoft is in their typical their typical form of embrace and something, fill in the blank. For many years it was embrace and displace. And with Linux, it may have to become a little something different. It's embrace and puppeteer. Embrace and be the master orchestrator of what's going on in all your Docker environments, all the automation of, Kubernetes-like environments. That's all going to be made easier, and you'll be able to have as many Docker instances of, virtual machine like Docker, instances running that maxes out your machine and, uses and creates a whole potential network ecosystem using just your one machine as its resources, just based on how it gets, sliced and diced out into units and presented as, machines to the network. And sometimes things are more tightly coupled than you'd expect them to be, to greatly positive results. There's a lot of things where you'd expect a server to be running and for there to be a client-server relationship, like the way if you want graphics under the Windows subsystem for Linux has to be right now with an X server in the picture, but lots of things work that way. The presumption usually is that there's a SQL server, not the Microsoft's brand SQL server, but there is a server on your network running the SQL service that you hit against when you're doing SQL, and then there's all the overhead of having to communicate with a TCP/IP network protocol, and then the results come back in TCP/IP as well, so there's all that network data parsing overhead. SQLite is an embedded SQL, meaning it doesn't have to have a server. It's part of the host environment that it gets compiled into, like in the way I'm using it right now, Python. The Python interpreter has the ability to run SQL when it needs to. And so a traditional network provided server service gets taken out of the picture. Such is the case, I believe, with inter-process communication if you use 0MQ for it. It's a message queue, which implies a message server similarly running in the background on some IP address, on some port, but it need not necessarily be so if you're not assuming a TCP/IP component architecture automatically, but rather if you assume that components can be baked into each other with API access to each other, so they talk to each other at a lower machine level than is possible with the TCP/IP protocol and everything expected to be there as a server. Such is the way with SQLite. Such is the way I believe with 0MQ. I need to learn more. So you got inter-process communication serverless. You've got SQL database serverless. You've got really fast data transforms with Python's native data types, its data object types, and its list comprehension syntax. Other syntaxes as well, of course, the standard, for item in iterable loop does come in handy, but in more handy comes inside that outer loop. Say you're using one of those 4 item in iterable loops, especially if you're using the context manager with something like a with open as file handle. That causes you to use a more iterable loop-like structure than you might be inclined to do if you were in a list comprehension. A single statement that could be turned into a list comprehension would make you want to stay single line, but as soon as the context manager was something that needs to be opened and closed, even if it implicitly is in the picture, you're going to be using your multi-lines and indenting. So you got that as your outer loop. But on your inner loop, for each JSON-like object that comes into view, that comes into context, which is at your current space or level, you look at it and you can see its keys there. And if you start doing list comprehension there, you can reach into that object according to its keys, iterate any sub-objects, do aggregates of sub-objects, and basically do the whole object walking routine. You might want to walk down through nested objects, or it might end up being that a series of simple list comprehensions are all you need. I'm thinking that the list comprehension is going to get back a list for each key in our raw data. So for each key in the raw data, a list comes back, because I'm not capping off. There's not going to be any empty rows. If there's a key there, there's data up to 5,000 rows. We step through that data and we do whatever we plan to do. And it's probably going to be an insert into a table, so it's kind on memory. This is a really good technique. See, I could build it in memory as I go, and then take that resulting object in memory and do anything I want, drop it all into a table in a single statement, turn it into a Python data frame. But it seems to me that I would be overlooking an opportunity to be kind to my host machine's memory, and perhaps even to create this in a way that it could handle ridiculously large lists, parse through ridiculously large source data. Because in your data frame, as you step through your key value pairs, which is SQL Server on the left, using SQLite third-party library to treat it as NoSQL, to treat it as native Python dictionaries, even though it's really SQLite in the background. But nonetheless, you get all the SQLite advantages. So potentially very, very large lists, not CPU or memory bound because of the way it pages through. It does generator tricks, essentially. Just has, thanks to the magic of pointers and access in the middle of file ability, the ability to step through very large files and not to have to load the whole thing into memory at once. And we would be walking away from that opportunity if we did not use that as the way to put the data back into a newly shaped table. So I will have a create table command, if not exists, create table, that does the keys, day and URL, that does the metrics columns of impressions, clicks, and average position. And there might be a click-through ratio as another data point there, but that's derivative. I don't even know if I particularly want to capture that. It can be recalculated. And so I store those 1, 2, 3, 4, 5 columns, where 2 of them are the primary key, into a table. And that's the next transform I have planned. And as I write them into the next table, I do them as a row at a time, as I get them a row at a time. So it's SQLite symmetrical, a row at a time out on the left, a row at a time in with an insert statement on the right. And thanks to primary keys, you can always rerun this. You'll never have duplicate data. Yeah. I got my next project planned out. I got 2 videos leading into it, and I got a bag of sushi for the peeps. So I'm going to be making a lot of people happy. And I'll probably push up this video as well. It's a good follow-on to that last video. It's a little bit of rambling, circa linear form. One of my listeners had a word for it. And I'll eventually get back to my original point. And pardon me, stop me before I sub-reference again. Dennis Miller, I believe, had the sub-referencing quote that I tend to use when I do that. And thanks for joining me. Hope to see you again soon, and don't forget to subscribe.